Hello everyone. Our math calculation lesson today is going to be about dimensional analysis. Dimensional analysis is used by engineers and chemists and makes a really excellent organizational formula for nurses to do dosage calculations. I think you're going to enjoy this method. Dimensional analysis is an organized mathematical system that reveals the relationship between units using algebraic rules. Well, let's just review a little bit of the algebra that we need in order to do this dimensional analysis properly. Let's multiply a fraction. 1/2 times 2/3 equals, well, because we're looking at the relationship between units and because we're using algebra, we're going to be allowed to cancel like units. This leaves us with an answer of 1/3, or 1/3. Now we want to ask, is that reasonable? Is half of 2/3 1/3? And indeed it is. 1/3 plus 1/3 equals 2/3. So that's reasonable. Let's look at another example of canceling like units. 3/4 times a whole number. We're going to multiply a fraction by a whole number. And remember that to multiply a fraction with a whole number, all we need to do to make the whole number into a fraction is put it over 1. We are going to cancel like units, which gives us 3/1, or 3. And we're going to ask, is this reasonable? Is 3/4 of 4 3? And it is. 1, 2, 3 is 3/4 of 4. 1, 2, 3, 4. So that's reasonable. Now, in order to have an organized mathematical system, we have to do it the same way every time. And the way to set up your dimensional analysis for drug dose calculation is to put the order on the left, and that's over 1 dose, no matter what the units are. In the next fraction, we're going to put what is on hand, whatever milligrams, milliliters, whatever units they are. And if they're not matching units, we're going to put our unit conversion factors over here. We're going to multiply across, we're going to cross out like units, and we're going to come up with an answer. Let's practice a few problems. Our order is for citalopram, 30 milligrams PO, and we want to know how many tablets to administer. So we're going to start by putting our order on the left-hand side in an organized fashion. We want 30 milligrams over 1 dose. We want our answer in tablets. So just to organize things nicely, I'm going to put tablets over here so I know what I'm looking for in my end result. In our pharmacy, we have 20 milligram tablets. So because we're going to want the milligrams to cross out and have our answer in tablets, I'm going to put milligrams on the bottom here. I'm going to cross out like units. I am going to also get rid of some of those zeros because we're allowed to do that in algebra. And I'm going to multiply across. 3/2. If we divide 3 by 2, we get 1.5. So our answer is 1.5 tablets. We always want to ask, is that reasonable? Well, 1 tablet contains 20 milligrams. So if 1 tab equals 20 milligrams, and we need 30, 1/2 of a tab equals 10 milligrams. And if we add those two together, we get 30 milligrams. And so, yes, 1.5 milligrams is reasonable. You don't always have to write this out, but sometimes it helps to visualize it in order for you to make the decision as to whether or not it's reasonable. Our next problem is dexamethasone, 40 milligrams IV. We want our answer in milliliters. On the left hand, organizational formula, I'm going to put the order 40 milligrams in one dose. Next, I'm going to go to the pharmacy, find out what I have in the pharmacy. And my available dose is 120 milligrams in 30 milliliters. This is a multi-purpose vial, a multi-dose vial. So I want my answer in milliliters. Again, in my organizational plan, I'm going to put that over here so I know just what I'm looking for. I'm going to take advantage of canceling milligrams and milligrams. I want my answer in milliliters. And I'm also going to take advantage of crossing out some of these zeros because we're allowed to do that in algebra. So 4 times 30 equals 120, and 1 times 12 equals 12. 120 divided by 12 equals 10. So our answer is 10 milliliters. Is that reasonable? Well, I'm just going to take a look at 120 milligrams and 30 milliliters. I want 40 milligrams, which is 1/3 of the amount of the milligrams. So 1/3 of the amount of milliliters would be 10. So this looks like a reasonable answer to me. Our next problem features some unit conversions. So our order is Synthroid, 1.5 milligrams by mouth. How many tablets are we going to need? So again, our organization has us set up the order on the left-hand side. 0.15 milligrams in one dose. We go to the pharmacy and we find that the tablets are 100 micrograms. So we're going to put 100 micrograms here and 1 tablet here. Now we want our answer in tablets. So again, to have our organization, we want to put that over here so we know what we're looking for. Now these units are not the same. So now we have to add that unit conversion step. We're going to want to cancel micrograms top to bottom, so I'm going to put 1,000 micrograms over 1 milligram. And now we're going to start to cancel like units. Milligrams cancel milligrams, micrograms cancel micrograms, so our answer is going to be in tablets. That's what we want. Let's cancel some of these zeros because we're allowed in algebra. So we're going to have 0.15 times 10 times 1 times 10 equals 1.5, and 1 times 1 times 1 equals 1. So we're going to have 1.5 tablets. Is that reasonable? Well, if we look at our label, it tells us that 100 micrograms is 0.1 milligram. 0.1 milligram would be 1 tablet, but we need 1.5 of those units. We need 0.1 and we also need 0.05. So a half a tablet is going to give us 0.05 and a whole tablet is going to give us 0.1. And if we multiply that times 10 to get our conversion, it's going to be 1.5 tablets. Now let's see how this method of looking for is it reasonable will help you to discern a medication error. Let's just say that our dose was 1.5 milligrams. How many tablets would we need? So we're going to set up our formula the same way, organized with the order on the left, 1.5 milligrams over 1 dose. And in the next fraction, we're going to put what we have in the pharmacy. And we know that that is 100 micrograms in 1 tablet. We want our answer in tablets, so we're going to put that over here. We need our conversion factor. We know that 1,000 micrograms equals 1 milligram. So we're going to, again, cancel our like units. We're going to cancel milligrams with milligrams. We're going to cancel micrograms with micrograms, and we're going to get rid of a couple of these zeros because we're allowed to do that. So we're going to take 1.5 times 1 times 10 equals 15. 1 times 1 times 1 equals 1. So 15 tablets. Is that reasonable? A dose, according to this bottle, of 1 tablet is 100 micrograms. This says we should give 15 tablets. I question that. If you find a situation that does not feel reasonable, how many times have you seen a prescription where you take 15 pills at once? Show this to your preceptor, show it to a nursing supervisor, ask the pharmacist to review your math, and get an order clarification. So here we discovered a medication error. It was ordered erroneously through our check method of is it reasonable? So to review, dimensional analysis as a method for us to organize our math calculations. We're always going to put the order on the left-hand side, the units that we have on hand in our pharmacy or Pyxis. If we need a unit conversion, that comes next, and we're going to cancel like units and come up with our correct answer. Our last item that we want to cover is it reasonable? Somehow, either do it mathematically, look at it rationally, ask yourself, is that a reasonable dose? And that's dimensional analysis. Thank you for your attention. I recommend that you watch the video maybe a couple of times, find some questions, some drug calculation questions on the internet, practice a little bit to prepare for your quiz later in the week. Have a great day.